Hello everybody. Today we are going to be talking about performance tuning and scaling strategies. So by the end of this module, we will understand performance bottlenecks and security systems, implement effective tuning strategies for security tools, design scalable security architectures, optimize security information event management and log management systems, plan capacity for growing security operations. Now, we're not directly going to be building out a SIEM or optimizing one, but this will give tips on how you would optimize one, right? So when we do get to those labs, that we'll be ready to know what the best way to optimize it is, how to plan for capacity, stuff like that. So you will already know the background of it. So for what is performance and tuning? It's a cybersecurity thing that involves optimizing security systems, tools, and processes to handle increasing workloads while maintaining effectiveness and efficiency. Poor performance can lead to missed threats, delayed incident response, and operational inefficiencies. So you got to think about, is this hardware able to handle this load and all these increasing workloads? Because your company's growing day by day, right? So it's scaling up, it's getting a lot more customers going to your website or whatever you're working on. And you need to think about that, how you tune it up, tune your existing systems, and upgrade for performance and stuff like that. So we have throughput, volume of data processed per unit time. This could be network input and output, meaning how much are you downloading and sending and stuff like that. So you need an appropriate network card and stuff like that. Latency is the time delay in processing security events. Just the time delay in any network. So you know whenever you go into like the command line, type in a command, and it takes a while to actually give you a response. That's that latency, right? Or it's just it's any time delay. So it could even be latency not related to the network, right? We also have resource utilization, CPU, memory, storage, and network usage. Availability, system uptime, and reliability. Meaning, are these systems going to be working? And are they going to be on when they actually need to be used, right? Detection rate, percentage of threats successfully identified. And we have hardware limitations, storage, input, output. Slow disk speed is definitely a limitation. Memory bottlenecks, inadequate RAM for data processing and caching. Caching is basically, we're caching this in memory, so when we do need to use it, it'll be ready for us to use. CPU constraints and insufficient processing power for complex analytics. Network bandwidth, limited capacity for data transmission, meaning you might not have a high network bandwidth, meaning your upload and download speed, you might not have very much upload, and it is messing with that bandwidth. So you only get so much upload and so much download, right, from your router that is then receiving internet from your internet service provider, right? Then we have software issues, inefficient algorithms, poorly optimized detection rules, and correlation logic. That could also relate to machine learning. Your machine learning might not be there might be some machine learning in the software that is poorly optimized, right? You might have database performance, slow queries, and inadequate indexing, meaning that your indexing wasn't set up correctly and it isn't set up efficiently. For configuration problems, we have suboptimal settings, reducing that system inefficiency, right? Efficiency. Resource leaks, memory leaks, and inefficient resource management. We have architectural limitations, single point of failure and non-redundant critical components, inadequate load distribution, uneven workload across resources, poor data flow design, right? Inefficient data processing pipelines. Pipelines heavily relate to DevOps, so you might have a CI or a CD, you might have a CI/CD, which is continuous integration, continuous delivery. You might have an inefficient pipeline that can't process that much data because the RAM is insufficient, right? It can't process data really, really fast that really, really fast memory could, because it's able to cache it and just boom. For SIEM performance, We have data collection optimization, prioritize critical log sources, filter unnecessary events at collection points, use efficient logs formatted structured versus unstructured, implement intelligent log sampling for high volume sources, meaning how you manage your logs. What are the most critical log sources, like the most critical, like stuff that could indicate that attacks are happening, stuff like that. Network optimization, they use log compression. Log compression makes it so the log files are a lot smaller in size, so it's easier to transfer them faster and more efficiently. But we have implement proper bandwidth management so that one of your pipelines isn't taking up all the bandwidth. We have deploy collection points strategically to minimize network hops. We have parsing and normalization. Precompiled regular expressions, optimize parsing rules for common log formats, implement caching for frequently parsed patterns, minimize complex transformations during real-time processing, meaning how fast you can parse out data efficiently. And a parser is basically just, oh, this field goes here, this field goes here. They didn't want this in the log format, so we're going to take this out of the log. So it's searching for those patterns, it's searching, and it's using the RAM caching, which uses RAM on that RAM, right? It's using RAM. It's caching it in the RAM so it's ready to use, right? And send out that parsed data faster. We have normalized common fields consistently, use appropriate data types for each field, implement efficient field extraction methods, meaning to be able to parse out that data and index out that data so that you can actually find data faster, you need common fields that are consistent, appropriate data types for each field, and that'll make your data more structured, meaning that you can index it better, stuff like that. For storage, we have index management. Create indexes on frequently queried fields, which will optimize for those indexes that you can just search them up a lot more quickly. Hey, all these logs are filtered out. I can filter this certain thing. And use composite indexes for complex queries. Regular, maintain, and rebuild indexes. Implement hot, warm, and cold storage tiers. Meaning, cold is something that you take, cold storage is something that you keep for years and years and years, right? Warm is like that in between. You keep it for, I don't know, half the time that you keep the cold for. And hot, you would just, boom, 7 days. We don't need that data anymore, right? Because that data you might not need that data to be compliant. So it's okay to get rid of that data. For data retention strategies, we have archive old data to cheaper storage. Implement intelligent data summarization. Use compression for historical data. Establish clear retention policies. So for this, right, this is holding on to that data for that certain amount of time, right? For row optimization, we have correlation row optimization. So correlating data types to different data types, right? Fields, correlating them to fields, right? You'll have rule efficiency, right? Optimize rule logic for performance. Use time-based windows appropriately. Implement rule priority systems. Regularly review and tune correlation rules. Meaning the rule priority, right? Certain rules have to be given, right? So they know how to handle these logs. And you just want to make sure that they're set up correctly, that configuration of configuring all those rules and stuff. But we also have resource management, limit concurrent correlation processes, implement rule scheduling for resource-intensive operations, use statistical sampling for high-volume correlations. Now we're getting to the scaling part of this. We have horizontal scaling. This is essentially scaling out with machines and machines and machines. Vertical is upgrading the hardware and then maybe scaling it a little bit. But a lot of people choose to do vertical scaling because it's cheaper to do vertical scaling, but it gets more expensive when you want to go horizontal, right? Because you're buying more and more systems that are the same without upgrading them and stuff. But it doesn't just relate to actual servers and PCs, right? It relates to microservices. It relates to, I don't know, Docker containers. You might scale out your Docker containers. So if one of your Docker's containers go down, boom, that other Docker container's taken over for that. Or it might be a Kubernetes one taking over. Or that's why I'm thinking microservices. I think scaling a bunch of containers, right? Having a script go make all these containers and link them together in some way so that they can do these load balancing things. So if one of them goes down, boom, that other one's going to take over for it. And if that one goes down, the other one's going to take over for it. For cloud scaling strategies, when I think of cloud scaling, right, I see, well, right here it's saying auto scaling, right? And I'm just thinking, is that really the best for the organization? Or should I just figure out what the organization needs instead of auto scaling it and then you have to pay this big bill, right? So when you think about that from a security standpoint and a financial standpoint, you're like, if it just scales by itself, it's going to use up all these resources and cost a bunch of money. And you have to think from an investment standpoint, what's the ROI going to be on this, right? And I see right here, spot instances, right? I see AWS use spot instances. That basically what a spot instance is what'll happen is that instance will delete itself after so long. So it's basically just to test out and say, oh, this will work. So then I can deploy it out to production because I tested it in a spot instance, right? But we also have reserved instances, which is like, I'm going to reserve all of these resources over this time, right? And I'm going to reserve this CPU, this RAM, because I know I'm going to be using it for, let's say I'm going to be using it for database, like we were talking about earlier, caching in the database and stuff like that, for database work and stuff. I don't know what it is from the top of my head, but I know it's something that has to do with databases. And I know there's a lot of different things you can do if you have a lot of RAM and databases for caching and stuff like that, which is really cool. But that is basically the scaling part of that. Optimize, and I'm saying like that cost is going to be insane if you choose to go with auto scaling. But the cost is also going to be insane if you choose to reserve it. But at least you know if you're reserving it, that's how much that's going to cost for the life cycle of that reserved instance. So you're reserving it over, I don't know how long, like a couple months to, I don't know if you can do it for years, but you probably could do it for years, honestly. I'll have to look into that. But for network security, right? Of course you're going to be talking about firewalls on here, right? So they're saying like, make sure the firewall rules are properly and efficient and not overdone, and you're using those rules for a reason. And you are monitoring that. So I mean, like, oh, this firewall, someone's trying to get into the firewall and do some stuff to it, but the firewall blocked it. So then you're getting all those logs and alerts, right? But now I see they have object groups. They have these groups, and I mean, like AWS has objects and object groups, right? Or firewall groups, whatever they're called, that will say, this is a firewall rule. Only this IP address is allowed to get through. And only this IP address is allowed to get through to this port. And that's a lot more security focused than saying any IP could go to this port, right? So I mean, next generation firewall is a good option, right? You got proper segmentation, right? Hardware acceleration, right? So you got to be thinking about these things and like these firewalls and stuff, because we are going to be building out a firewall in this course. I think what is it? OPN Sense, or what's the other one? But we have OPN Sense, and there's another one, and probably going to be using Docker containers, and we're definitely are going to be learning about Kubernetes. But let's get on with it. You should have learned if you took the Security Plus about this, but this is going to be going over, best practices and everything, right? Intrusion detection system, for you guys that haven't taken Security Plus, right? That is, I'm detecting that this thing's coming through, right? You are getting all these logs in the IDS system. And intrusion prevention system would actually prevent those attacks from occurring. And I mean, tuning, right? Those signatures, right, are basically, we know this malware signatures, right? You have malware signatures, and they're like, this malware has this certain, and there's false positives all the time, but you go put a program up in VirusTotal, you'll be getting all these false positives, and that's how I like to think about it. But monitoring those signature managements, right? Performance, and I like to think that IDS and IPS stems kind of from firewalls and stuff, but they sort of don't because they might be sitting on the inside of the firewall, right? So they aren't just a firewall, but some IDSs and IPSs may be built into firewalls, but they probably do have IDSs and IPSs, intrusion detection systems and intrusion prevention systems that do work without being, how do I say it, connected to a firewall or integrated with a firewall. Because I know that like Cisco firewalls probably have the same things, and I know they have DDoS protection on some of them. Because I did mess with Python and how to stop those DNS attacks, DDoS attacks, distributed denial of service attacks, and I was sending it from the attacker VM or computer to my firewall, right? And it was getting it. And I mean, it was actually the script that they had on there was actually, and this was all in a test environment that Cisco made. I think Cisco Labs or something. I'll link it up here on the page. But web application firewalls, they are really, really good. We got positivity security models, where security models are like just knowing what you need to do, right? But even if you knew what to do, there'll still be some vulnerabilities in your stuff that you're going to have to watch out for. Tune the rules to reduce false positive. That'll be your signatures, right? Or your policies. You have learning modes to optimize policy. Implement rate limiting and DDoS protection. And that's very important because on the router that I was using with the Cisco router, right? It had DDoS protection, and it would just stop those attacks that are coming in. It was like an intrusion prevention system. It saw that the attack was coming in. It ran that Python script to block that attacker's attacks, right? And that's what you got to start thinking about. How to prevent DDoS attacks and the solutions that are already out there. Like Cisco, of course, has solutions to block DDoS attacks. But, I mean, there's still vulnerabilities and everything, right? Even though it could stop it, it still had to detect it. It still had to prevent it by blocking that IP address whenever I was doing that lab. But for endpoint security scaling, we have agent deployment strategies, which is like stage deployment approaches, implement centralized. And I will show you guys that lab on I'll show you that. I might even show you that lab right now. It was like, what was it? Cisco lab? Cisco Learning Labs, maybe. It definitely wasn't this, but I mean, I'm actually pretty sure it was Cisco DevNet, where I worked in a sandbox to stop that attack. And you just go launch, and it'll bring you up here. You log in. I'll log in. But here we are. We do have all these different labs that Cisco does offer. And I'll just look up DDoS protection, right? Do they even have it? DevNet self-service, right? Operation Hub. And this was probably the lab I did, which is right here. So we do look right here, and we have secure DDoS protection with NCS, which I did work on, which is edge protection, where I used that router to, sort of block those attacks. But if we go back to endpoint security, right? We have agent deployment, resource management, central management optimization, capacity planning, growth projection models, analyze past growth patterns, consider business expansion plans, factor in new technology adoptions, account for seasonal variations, right? So you got to think about that. For statistical models for forecasting, we have consider multiple growth scenarios, factor in external influences, regular model validation and adjustment, resource planning, hardware planning, which is basically just planning the resources that you're going to need, planning out what software license you need, and baseline establishment. What is your baseline that you need and your performance needs, and just making benchmarks of that. Establish alerting threshold when you're over a certain baseline. Regular baseline reviews and updates, right? What is a baseline? A baseline is basically what your system is capable of doing on a hardware and software level. So like CPU, memory, RAM, GPU, just some of the things that you got to think about. And implement comprehensive performance monitoring. And the reason they say secure baselines is for those performance benchmarks, those making sure everything is like secured down and reviewed regularly. For continuous monitoring, you can see that in CI/CD pipelines, right? Continuous integration and continuous delivery pipelines. You can see that. Performance monitoring, automated alerting, performance, regular performance, trend analysis, and capacity planning updates. For optimization, we have methodologies, performance testing, load testing to simulate expected workloads, test scalability, and stress testing your systems, right? Trying to find what their failure points are to know if you need to upgrade or not, or certain bottlenecks will happen, right? And if you're doing it in the cloud, it'll cost you a lot of money. But keeping that cost down and being within your budget is very, very important because you don't want to overspend. So some metrics to track. Resources, yeah, definitely I'd want to do that. And response times, latency, you want to definitely know what your latency and stuff is. Throughput is and processing rates, meaning how much data can I push through this system and out of this system in this amount of time. And what is the rate? How many logs can I transfer in a minute, in a second, in an hour? Error rates, availability, user experience metrics. And you got like monitoring tools, application performance monitoring platforms. And I mean, they do have monitoring platforms in the cloud. Like, what is it? Prometheus that just monitors like literally everything. Don't quote me on that, but it does monitor a lot of stuff that you can monitor and track stuff. You have infrastructure monitoring, but keep in mind if you're using Prometheus, that stuff is going to be in the cloud. But we have custom dashboards and reporting. So I see continuous improvement. You always want to be improving and optimizing your environment and stuff like that. That's why everything that is showing on here is very important. So non-production environments, change management is what I think when I think test changes, non-production environments, implement rollback procedures, stuff like that. I just think change management. Oh, I didn't see that. But we have plan for scalability from the beginning, implement monitoring, alerting early, use standardized configurations, document all optimization efforts, regularly performance reviews, right? Start with the baseline measurements, right? What you think you'll need. Don't go for that crazy setup until you think you're going to need it, right? Then you implement changes incrementally. Say you're like, oh, my RAM I don't have enough RAM. Then you could start thinking about and implement those changes when you want to upgrade your RAM and stuff. Test all changes thoroughly. Monitor impact continuously. Maintain detailed documentation. It might be, and I mean the key thing right here, if I can't teach you anything else from this, maintain detailed documentation on everything. If you did not learn anything from this, I want you to at least learn maintaining detailed documentation. Most important thing in cybersecurity. Over-optimization without clear benefits, ignoring security while optimizing performance, lack of proper testing before implementation, inadequate monitoring and alerting, poor documentation of changes. Document everything. I mean, like I said, if I can't teach you anything from this video, I at least want you to know to document everything in a optimized and efficient way. Meaning, don't just write stuff for no reason. Yeah, I want you to write down notes and stuff, but make a GitHub and post your docs on there. It might actually help somebody. You never know. But I mean, here's the scenario-based things. I'm not going to read them all out. But we do have exam preparation tips, understanding performance bottlenecks in security system, meaning resource requirements, stuff like that. We have SIEM, which is Security Information Event Management System, optimization techniques and strategies, scaling methodologies, horizontal versus vertical. I'm pretty sure you guys got that pretty good. I think my explanation was all right, but you guys can tell me in the comments. Capacity planning principles and methods, performance monitoring, and baseline establishments. We just got common questions that might be on the test. Might be on the test. I mean, I'm not saying they're going to be on the test or not. I haven't even taken the test, so identifying appropriate scaling strategies for given scenarios. Optimize SIEM. So those are all like the tips that I'll give you. Knowing everything I've showed in this course, right, is very important. Recommendations for studying, and I'm just going to end it off with this. Include the importance of established baselines, implementing comprehensive monitoring, planning for scalability from the beginning, and maintaining a balance between performance optimization and security effectiveness. Success in this area requires a combination of technical knowledge, practical experience, and strategic thinking about future growth and requirements. And if it's the only thing I can teach you in this video, if you didn't learn any of this stuff, documentation is the most important thing in security. Thank you all for watching. In the next video, we will be talking about log ingestion a little bit more.